Welcome back to Grade 8 Math. We are now looking at Chapter 3.4, Lesson 3.4. We're almost done the chapter. We have just a couple more lessons. This one's on histograms. And as we looked at the beginning of this chapter, histograms are very similar to bar graphs. But what they basically look at is we are chunking our data into intervals. Last year we looked at frequency tables and we looked at stem and leaf plots, and this is basically an extension of stem and leaf plots or frequency tables with that. So here's the example. James is practicing for a bike race. The following is his time in minutes to bike 2 kilometers. And so we have a bunch of data points. It was all converted into decimal rather than using seconds. Might be easier just to use decimals anyway. So let's first of all just look at the total frequency just to see what our normal answer of all of our total data points should be, or the total number of them. And I have 3 times 8, and 3 times 8 is 24. So my total frequency, which is represented by the letter n equals 24, which means I have 24 total data points that I have to add up at the end, or I have to see that I have 24 data points. So steps in creating the histogram. The first thing is to find the range, and the range is the spread between the highest and the lowest values. So if I look on my data points, I have 6.8 is my lowest, and I think 9.6 is my highest. So my range goes from 6.8 to 9.6. So now I'm going to choose appropriate intervals depending on the range. So sometimes between, well, not 5, 4 to 10 intervals are best. So I can look at my numbers and see how I want to divide them. So if I take a look, let's just try one example. I can start from 6 and then go to 7, then 7 to 8, 8 to 9, then 9 to 10. So there I have 4 intervals, and now they move from one to the next. Now what I'm going to do is I'm going to chunk all this data, which means I'm going to combine them. I'm going to put them all together to fit in within that interval. If you notice, there are two numbers that are the same. The reason for that is because I have decimal points, I might have numbers that will fall now exactly in between those two intervals. So now I have to go to exactly each one. And when we actually start plotting them, we'll see where a data point would end up. Another example of intervals might be half intervals. So instead of starting at 6, because my range doesn't start at 6, it starts at 6.8. But I want to make it clean, so I'll start at 6.5 instead. And what I'll do is I'll go then by intervals of 0.5. So 6.5 to 7.0, 7.0 to 7.5, 7.5 to 8, 8 to 8.5, 8.5 to 9, 9 to 9.5, and then 9.5 to 10.0. Let's just make it consistent, put all the decimals in there. Great, so I can choose these intervals or I can choose those intervals. What I'd like you to do is pause the video. Before you do that, we're going to start creating our frequency table, and we'll be putting our numbers in there. Now, if we have a number that lands directly on the edge between two intervals, so for example, the number 7.0, we don't put it in both intervals, we put it in the higher interval. This is just a convention of mathematics. There's no real reason why. It's just out of consistency, we'll always choose the higher interval. So for example, the number 7.0 will fall in the higher interval and not in the lower interval. So what we'll put the titles in our frequency table. We have our interval, and in this case, this is minutes. It's very important to put our units in the table so that at least we know exactly what those intervals represent. Then we'll have our tally in the middle, and then we will have our actual frequency. So what I'd like you to do is choose the interval that you would like, either the larger intervals or the smaller intervals, and then put the intervals down, do a tally of how many numbers fall within that interval, and then the frequency, just convert the tallies into frequencies. So after you've tallied them up, let's just take a look to see what you got. So I'll just do the larger intervals for the sake of time. You may have done the more narrow intervals, and we'll see what we get. So we get a total of 2 here. We have 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, and we have 3. I already did this. I looked at the numbers up there and I put them in their appropriate intervals. So now I can just convert these over to frequencies. And then now I can just analyze that information. Now let's look at the difference between why we would use one over the other. If I use smaller intervals, so this is in case of number 2. If I use smaller intervals, My answers are more precise because now I know exactly under which interval will fall under. The problem with smaller intervals, though, is that I spread out the data, which basically means I might not have an idea of which category is indeed higher than the rest. If I have larger intervals, so in the case that I chose right now, this gives you a more general idea of which category has the highest frequency. The drawback, though, of larger intervals is that I lose precision. So, for example, between 7 and 8, I know there's 12, but is it really more between 7 and 7.5, or is there more between 7.5 and 8? So I lose that kind of precision with my answers, or with my graph. So now let's start graphing this up. Now, because we got to choose the intervals, because the intervals are really up to us to decide, that becomes the independent variable. So this is now on the x-axis. I'm not sure if I have a little room. So the intervals happen on the x-axis. So this is my x-axis. So I'll choose from 6 to 7, 7 to 8, 8 to 9, and 9 to 10. And then what I have up here are the frequencies. So the intervals are independent because I get to choose them. And so now I'll just go up by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Should be using a ruler for this. These numbers should actually be below the axis, not on the axis. I just ran out of room. Let me just see if I can get a little bit extra space here. Oops, jumping all over the place. And here we are. So let's just fix these intervals. So I have 6 to 7, 7 to 8, 8 to 9, 9 to 10. Equally, I could just put them in bars and say that this is the 6 to 7 range, this is 7 to 8, so this is OR, 8 to 9, and 9 to 10. Both will work. If I wanted to make it look like a line graph or like a bar graph, both of these will work. So between 6 and 7, I have a total of 2 data points. Between 7 and 8, I have a total of 12 data points. I should be using a ruler for this. It's hard to use a ruler on the computer. And color it nicely, nicer than that, I hope. And then between 9 and 10, I have 3 data points. Wow, it's a terrible looking graph, but hopefully you understand the idea from it. Now notice in the histogram there are no gaps in between each of these bars. The reason why is we call this continuous because we're chunking all the information into one continuous line or axis. And the title of this would be the James's bicycle times bike times, or 2-kilometer bike times. Great, so if you take a look at your graph, it might look like this. If you choose smaller intervals, then you might end up with a different looking graph. But we'll take a look at these 5 examples in class, and hopefully you'll be able to, if you have any questions, to ask that in class. So as we just review again, frequency tables can be used if we use the intervals that are continuous and that chunk together. We can use that to make a histogram, which is basically like a bar graph, but it's one continuous bar graph that is chunked into information. So